Hello everyone. So, this is a somewhat advanced function transformation problem. But let's see what we can do. So, it says the graph on the right is our f of x, and it wants us to graph y equals 1 half times 2x minus, or f of 2x minus 1 plus 3. So, in order to get started, I'm going to graph the endpoints and the points where our graph is going to switch directions. So there's like little corner points. So we have negative 4 and negative 2. We have negative 2, positive 1. We have 1 and negative 3. We also have 3 and 2. So, those are my points on f of x. There we go. I'm just going to list them out. Again, and you'll see why in a second. Oh, what am I doing? And 1, negative 3, and 3, 2. Alright, so how I would approach this problem is I'm going to take just the function without all the stuff on the outside, without the 1 half and without the plus 3. Just going to look at f of 2x minus 1. Now, the point in doing that is what I want to do is think of it like this. You want this value of the function to get you the same y value on f of x for now. Because all the stuff on the outside, that 1 half and the plus 3, that's going to affect the y value. But you want to affect the y value after you've taken care of the appropriate x value, your input. And just keep in mind all your points are x, comma, f of x. That's what I mean by the y value, the output of your function. So, for example, if I want my output to be negative 2, so it corresponds with the output on the original function. What is my new x value? What value do I have to use to plug in for x to get that appropriate output? Well, I know that negative 4 and negative 2 is the point, and that tells me that 4, or f of negative 4, is equal to negative 2. So I want what's on the inside of the function, the input side, to eventually come out to equal negative 4. So how do I find out the appropriate x value? Well, you just make an equation. 2x minus 1 equals negative 4. And now I can find my appropriate y value. So I'm going to add 1 on both sides to get negative 3 equals 2x, which implies that x is equal to negative 3 over 2. So, when x is negative 3 over 2, it gives me my desired output of negative 2. So, let's erase some of this work. And what I'm going to do now, keeping in mind that's my x value, is I'm going to say 1 half f of 2x minus 1 plus 3 points. And I'm just going to label my 4 points preemptively. And now I know one of my x values is negative 3 over 2. But I'm going to leave the y values alone for now. We'll modify the y values after. So now another input I need is a -2 because I want that output of 1. So again, what value can I plug in here that will ultimately result in the whole input becoming a -2, just as we have here? Well, again, we're just going to do 2x minus 1 equals -2. Add 1 on both sides. We have 2x equals -1, and therefore x is -1/2. So that's going to be my second x value. And this is the process we will be doing to discover our x values. So now we want 2x minus 1 equals, right, the regular one for our third point. Add 1 on both sides. 2x equals 2, which implies x is 1. So we have a 1. And after that, we want 2x minus 1 to equal 3. 2x would therefore equal 4, and x is 2. So those are all my x values. So now you might be asking, well, how am I going to deal with the y values of the function? How are they going to be altered? Well, let's write out one example, and you'll basically see the gist. So I'm going to now write my 1/2, and I'm going to start with my x of -3/2. So we have 2 times -3/2 minus 1 plus 3. So this is going to simplify to 1/2. Oh, I forgot to put an f there. Sorry, f of. And we already know that this should get us a result of -4, but just to do the math, 2 times -3/2 becomes a -3, minus 1 is the -4. And then we have plus 3. Now, we know f of -4 gives us an output of -2. So, we have 1/2 times -2 plus 3. And -1/2 times -2 is -1, plus 3 is equal to 2. So that's going to be the y value of my new point. Or I'm sorry, that first point. And that's really all you have to do to get your y values. So instead of writing it out the long way I just did, I'm just going to take my y values. So my next y value is a 1, corresponding with this point, of course, and multiply it by 1/2 and add a 3. Well, that just becomes 3.5, 3.5, or it would just become a 7/2. And so we have 7/2. Okay, now we have -3. So 1/2 times -3 and plus 3. Well, that's -3/2 and plus 3, which is the same thing as 6/2, which we can reduce as just plain 3/2. And then finally, we have 1/2 times 2 plus 3, which is equal to 1 plus 3, which is equal to 4. And now we have all the points we need. So let's start graphing. Our first point is -3 over 2, which is negative 1.5, comma 2. So over 1, or wait. Over 1.5 and up 2. Then we have negative 1/2 and 7 over 2, which is that 3.5. So negative 1/2 up 3.5. So somewhere around there. Then we have 1 and 3 over 2, or 1 and up 1.5. And then we have 2 and 4. It's right there. So now if we complete the graph, connect our points. Oh, whoops, wrong. We want the segment tool. We get our beautiful graph that has been compressed down horizontally and vertically and shifted around a bit. And that completes the function transformation of this fairly complicated transformation.